check and make sure we have volume. Sure.
Wait, why are you recording this?
Are you gonna sing or no?
All right, 16. 16. Consider the velocity equation. V equals t squared. T squared cosine t squared sine 2t, where S0 is 0.5. Use a graphing utility to calculate the following. Okay, I'll tell you the wrong way to do this. The wrong way to do this is to attempt to integrate by hand. Why is that the wrong way? Yes. Tells you to do it on your calculator. Also, you don't know how to integrate a product. Okay, you have not learned integration of a product. There is no product rule for integrals. In fact, there is no quotient rule for integrals. If you see a product or a quotient rule, that means that a product or a quotient, that means there's a trick you need to do. We're not going to learn that trick yet, but we are going to learn to evaluate this integral. So firstly, get to y equals. Notice I have plot 1 on. I'm going to turn that off because I'm not in stats anymore. Now I'm going to put this function. Okay, do not use t, use x. So this is x squared times the cosine of x squared times the sine of 2x okay? Take a second to put that in your calculator. Okay. Going to the home screen, we're going to evaluate this. We want to take the integral, so if you don't remember where the integral is, it is alpha f2. Integral is number 4, fn int. We're going to integrate from 0 to 2. The function that we want to put there is in y1. y1 dx. 0.72. Wait, am I in radians mode? Yes, I am. How do I know mine's in radians mode? Oh, it says radian on top. Needs to be in radians. Calculus is always in radians. Okay, so can we remember that? 0.785. So what is that? 16a? There's really nothing to no work to show.
How many digits do you want again?
3. That's it. There's no work to show. Why won't you? That's better. Okay. Letter B. Write an integral expression that gives a position at 2. Okay, here's your integral. Do you remember the antiderivative of velocity? It is position. The derivative of position, s prime of t, equals velocity, right? Therefore, the integral from 0 to 2, from 0 to 2 of velocity of t, that's equal to the integral from 0 to 2 of s prime of t dt.
Can you repeat that again, like the logic behind it?
Because s prime is equal to v,
Okay, just like what is that again?
the position,
Okay, so the derivative position is
velocity, right? Okay, and if you remember from the fundamental theorem of calculus, the integral of a derivative is just the function s2 minus s0. Right?
Yeah.
Great. We're going to flip this around. We're going to make some substitutions, okay? We are told that S0 is 0.5. Again, it's given in the question. I'm not making it up. I mean, I made up the question, but that 0.5 comes from the question.
Wait, okay, so that's up to when you wrote the equation, that's part B? And then C
No.
is
We haven't gotten to C. This is all part B. Okay, lastly, you're going to solve for S2. Look at that. S2 equals 0.5 plus the integral from 0 to 2 of velocity.
What does it say? Oh, S equals,
Can you scroll up a little bit? Just add a 0.5. Add a 0.5 to both sides.
Algebra. Alright, so that's an integral expression that gives a value of s at t equals 2. Okay?
We don't need to find the number.
Now, that's next. Part C. Let's actually find S2, the position at 2. Okay, 0.5 plus. That's from part C, part B, right? Okay. 0.5 plus, was it 782? 0.785. 0.785 is from part A. That's not hard, right? What's so hard about calculus? I don't get it.
Like, when I go home today, it's not gonna be there.
There are things that are simple, but you think is so hard, but much rather stuff is hard.
There will be difficult things. This isn't it. Okay, letter D. Find the average velocity. Do you remember what we said? Any average is always going to be an integral expression. Any average is an integral. What are we finding the average of? And what are we finding the average of? We're finding the average of? We're finding the average of velocity. So that means I need to integrate velocity. Okay. If you're finding the average velocity, you need to integrate velocity. finding average velocity, you need to integrate velocity. Every average is an integral.
We've already done that.
And we've already done this. That's equal to
0.392, 0.393 technically.
39 what?
25.
3925.
E. When does the velocity first reach the average velocity? When is the velocity equal to 0.3925? When is
Time.
t squared sine of t squared cosine of t squared sine of 2t, when is that equal to 0.3925? This is when you learn, this is when you use essential skill on the calculator number 1, solve an equation. Okay. You know what's nice about this? I already have this function in my calculator.
Do you plug it into the other one?
Yeah, so y2 I'm going to put 3925. Y2 I'm going to put 0 3925, yeah. Okay, these are going to be very confusing unless you narrow your window. So go to window. What's my interval for x going to be? 0 to 2, yeah. How do I know it's 0 to 2? Because that's what they tell ya. Okay, what should be my y minimum? Wait, hold on. What y value am I concerned with the most here? 0.3925. 0 to 1 will work on it. Whatever I use, I need to make sure I capture 3925. Push graph. Boom, there's that weird trig function again. I'm only looking at a portion of it though, right? Yeah. The whole, if you graph the whole thing, I've intentionally confuzzled you. Trust me, it's done on purpose. Okay. How many times is the function equal to its average? 3 times. I need to find the x-coordinate for the first one. Do we remember how to find an intersection?
Yes.
Now's the time to do it. Second, calc. Intersect. Is my cursor on the first curve? Yes, push enter. Is my cursor on the second curve? Yes. Is that a good guesstimate? Yeah. What's the actual answer? 0.6689. Great. Yeah.
I with my cursor, I didn't go left, I went right, so I got 1.07.
Yeah, you have to make sure you put the when it asks for a guess, you need to make sure you put the cursor close to the intersection you need.
I did put it, but I didn't put it on that intersection, I put it on the other.
That's from first intersection.
You have to ask for the it does ask for the first intersection.
So then we put the point on that intersection.
I'm sorry?
You can, well, so we just go back.
I have to start again if I do anything.
Oh, okay.
Okay, so that's the answer. That's going to happen when t equals 6689. This will occur when t equals 6689. And you're done. Do you need to show work? Well, yes and no. You need to show the equation here, but you don't have to show me how you got this number. I'm assuming you use your calculator to get this number. Yeah, you're not solving this by hand. If you try to solve this by hand, you have fallen into trap number 16. Okay. Further questions on that? Does everyone have their intersect done? Laura, are you teaching them how to do this? Okay. Can we go on to the next one? Awesome. And for this one, okay, let's take a look at 17a. Horrible, horrible. That's a bad line. That's a better one. Okay. Here is your paper. I'm gonna trim this just a little bit. If you give me a second, I'll do that. Where is crop? Anyone see crop? Format? I don't know. Crop. All right, this is enough.
Is that a picture?
Enough of this. I'm going to use screen clipping. Clip. Perfect, that's better. Okay. Here's what I'm going to do, and you probably should do this too. I'm going to figure out the area of each of these shapes. Okay, so this shape is a triangle with a base of 4 and a height of 4 as well.
8.
That has an area of 8. This right here is a semicircle. It has a radius of 1.5. And so the area is equal to 1/2 of, radius is 1.5, which is 3/2.
What's the equation for the area of a semicircle?
Half of pi r squared. So is that 9/8 pi? Great. And this right here, triangle, base 1, height 2, that has an area of 1. Okay. Smart money. Put the areas in first. You don't even know what you're doing here, but you're putting in the areas first. Okay? Part A. Actually, we should read. For the graph V, all the lines are either straight or semicircular. The coordinates of each intersection point is listed. The position of the graph is given by x of t, not explicitly given. When t equals 0, the value of x is equal to 5. What the heck does all that mean? Yeah.
It says that all of the values, the coordinates of each intersection are given, but it doesn't say 7, 0. I just want to make sure that that's the
Yeah, it's 7, 0. Okay, so basically what you're just told right there is that x evaluated at 0 is how much? 5. Great. Okay, so we're going to do some integral expressions. First question, what is x of 0? 5. How do you know that? It's given. Good. Next one. You need to find x at 4. Is there an integral expression I can use to find x at 4?
Yeah.
The integral from 0 to 4 of x prime of t equals x4 minus x0. I forgot one more clue. X prime of t equals velocity of t.
How do you know?
It's always given. Yeah.
Where do you see x? Where do you get x prime from?
You don't, but you have velocity. And you need to know that velocity is always the derivative of position. That's one of those standing in the back of your head always. Okay, so we're ready to do this. Do I know the integral from 0 to 4 of x prime?
Wait, why are you doing x prime?
Yeah, because it's the area.
Because that's the same thing as 0 to 4 of v of t. Again, x prime is velocity. Change of position is velocity. What is v of t from 0 to 4? It is not 8.
up, Mr.
Hey,
Perry?
we're really busy right now.
Oh, y'all doing a lot.
Negative 8. Thank you. Negative 8 is equal to x4 minus, do I know x0?
5.
It is 5, right. Where does all this stuff come from?
This still all is.
Given. Or
It's
we
not
call
given,
it-
or we like.
This is area, right? This one is given. And now you just solve for x4, right? x4 equals negative 3. Questions on that?
That was all a.
That we're not done with it yet.
So that's find the value.
How do I do which?
How do you find the value? Oh, x equals. Oh, they give you.
Okay, how can I get the position at 7? Oh, go ahead.
And then can you reiterate why x prime of t is?
It's one of those, because x is a position function.
Integral from 4 to.
So the derivative of position is equal to velocity. It's one of the standing things that you should always have, or you should always know. The derivative of position is always velocity.
Wait,
Yeah.
Didn't we find, wasn't the area of that positive 8? Why is
It,
it negative
it
8?
was. The area is positive 8, but the integral is negative 8 because it's below the axis.
The integral, oh, it's because it's the area under the curve, right.
Exactly.
That's right.
Okay. Any other good questions? I know that we didn't talk a whole lot about the derivative of position being velocity, but I think that's one of the things that you're supposed to get last semester. The derivative of position is always velocity, and the derivative of velocity is acceleration, yeah. Okay, the next one is a position at 7. Is there an integral expression I can use for 7?
4 to 7.
Yes, right. From 4 to 7 of velocity.
Why you do 4 to 7 on 0 to 7?
We could do 0 to 7.
But they need to add up the area.
We could do 0 to 7 if we really wanted to, but then we'd have multiple areas to put together. Okay, can you tell me Integral from 4 to 7 of velocity, what does that equal to?
X of 7 minus X of 4.
That's the fundamental theorem again, right? Look how fundamental it is.
Isn't it the, I don't know.
How do you know to do etch from 4 to 7?
You have to use something. You know you want one of them to be 7. And you have to start with something that you know. We know 4, we don't know 7. Okay, can you tell me the integral of velocity from 4 to 7?
9 pi over 8.
How do you know that? I don't even know how you got negative 8 on that one.
That's the area. 9 pi over
It's 9 pi over 8, right?
How do you know that? You know the area of the triangle?
We found it already. Right there, it's not there.
It's a semicircle. Geometry, that's how. Okay, so, oh wait, I'm sorry, was that 9 pi over 8?
Yeah.
So 9 pi over 8 equals the position at 7. What's the position at 4?
Negative 3.
Okay, so we're going to add negative 3 to both sides. So that's going to be 9 pi over 8 minus 3 equals x of 7. Can I turn that into a decimal? Yes. Only thing I want you not to do is to mix up decimals and pies. Okay? If it's a decimal, keep it all decimal. If it's rational, keep it all rational. Any question? Okay, how are we going to find the position at 8?
What do you get when you use decimals?
Hmm?
What do you get when you get
0.5342.
Okay.
How can I find position at 8?
From 7 to
Everyone, how can I find position at 8?
You do 7 to 8.
Good. X prime, which is velocity. And that's going to get me position at 8 minus position at 7. What's the integral from 7 to 8?
1.
It's 1. How do I know it's 1?
1/2.
It's the area. 1/2 base times height. Yeah. X8. Do I know what X7 is?
Yes.
What is it?
6.53.
9 pi over 8 minus 3. That is so ugly looking.
Can't put the decimal.
You got rid of the
You could put the decimal, but I prefer not to. Okay, so we're going to add this to both sides, right? So this is going to be 1 plus 9 pi over 8 minus 3 equals x at 8. So we get 9 pi over 8 minus 2. Okay?
So you want the answer like that or in decimal?
Either way is fine. I prefer this. That is all part A. Part B. Sorry, no rest for the wicked.
I love that song.
B, bravo. B. Can you find the integral from 0 to 8 of VT? Good. We just have to add those areas together, right? What's the first one?
Which case 5?
What's the second one?
What?
What's the third one? Look at that. That wasn't hard, right?
No.
Letter C.
You don't add it, really.
No. It's perfectly fine the way it is.
I have a you know how you're doing like you're plugging in velocity, how do you like know which one to plug in?
Based on 0 and 8 over here. Basically, this says add all the areas between 0 and 8.
No, not for D. Like for 7 to 8.
Uh-huh.
Part A. How do you know to plug in one?
Because the area from 7 to 8 is 1.
Okay.
Okay, letter C. Find open intervals where x is increasing and open intervals where x is decreasing. This is a calculus A question. Okay? How do I know if x is increasing? It has a slope that is positive. So basically we're going to find out when is x prime greater than 0.
Can't do it based off of the graph.
Yeah, can you do it?
Yeah, look at the graph. When is x prime greater than 0?
From 0 to 4. Wait, no, 4 to 7 or 7 to 8.
Good. Don't be tricked. You're looking at a graph of x prime. You're looking at a graph of x prime. X prime is positive if the line is above the x-axis.
4 to 7.
From 4 to 7.
And 7
So
to 8.
Is it just 4 to 8?
no.
Oh, because 7 is 0.
Okay? Therefore, x increases for t between 4 and 7 and 7 and 8.
This is a graph of x prime. Isn't the question asking where x
Yes.
increases?
X increases when x prime is positive.
Alright.
Okay, we're going to do, likewise, we're going to do the opposite of this. When is x prime less than 0?
0 to 4.
Yeah, that's easy. That's for t between 0 and 4. Again, this is a calculus A question. You should have this down. Therefore, x decreases for t between 0 and 4. Questions on C? Great. Letter D. This is another calculus A question. This is calculus A. X has a relative extrema. I forgot the word extrema, sorry. Has relative extrema on this given interval. What is a coordinate of the relative minimum? Let me ask the question in another way. What value of t is the relative minimum? When t equals, let me get back up. How do I know that a function has a relative minimum based on the graph of its derivative? Not when it's 0.
If it increases and
Okay, if x increases and decreases, then we get a relative maximum.
decreases.
If x decreases and increases, we get a relative minimum. Okay, but wait. We need to find when x is decreasing or increasing. Do I have a graph of x? No, I have a graph of v, which is the derivative of x. So what am I looking for in the derivative?
Where it goes from negative to positive.
Okay. We're looking for when the derivative goes from negative to positive. Okay? So let me write that. Let me type that. X has a minimum when x prime of t changes from negative to positive. Any problems with that? Okay. I'm going to change x prime. I'm going to change it to v of t. Any problems with it now? No. Good. When does v go from negative to positive? Good. V of t changes from negative to positive at t equals 4. Can everyone see that? Good. What's the x coordinate at 4?
-3. No, 0.
What was x of 4?
-3. We found it. -3.
That was from part A, right?
Yeah.
You're gonna speak Russian, always do it, right? So listen to it.
That's it. All right, did we find the coordinate of the relative minimum? Yeah, we did. What's the coordinate? 4, -3, yeah. Did we explain why it's a negative? Why it's a minimum?
Yeah, it changes from negative to positive.
Because v is changing from negative to positive. Because x prime is changing from negative to positive. Are we done?
Party.
Part E. Last one.
Are they all gonna have a party in the bed?
No.
Like from ABC?
No, they're not going to have 5 parts. E. Find the average velocity. Hey, how do I find an average velocity? Wait, what do I need to integrate? Good. If I want to find an average velocity, I have to integrate velocity. Good. Do I have a number for the velocity?
Yeah. 9 pi over 8 minus 7.
Did you say -7?
Yeah. I think so, yeah.
What part was that from?
B. Part B.
Oh God, what is this? 9 pi?
Over 64 minus 7 over 8. Yeah, you got the answer written down.
Should I LCD that?
No, let's just leave it. Let's just release. No,
56.
no. Brian knows it. Brian, can you say DPO?
Oh my gosh.
If we didn't take that last step, just left it at 9.65 minus 7.
You're okay.
We get full credit for the step right before that one, 9 pi over 8 minus 7.
Okay. Last questions.
What about the multiple choice part?